great honor to have this opportunity to be presenting our project on the Year Infrastructure 2022. My name is Kisuf Ramadan. As BIM coordinator, we got something to tell you about Integrated High-Speed Railway and Station, Jakarta, Bandung. The new high-speed railway will be the first in Southeast Asia and connect two larger cities, Jakarta, Bandung. The distance between Jakarta and Bandung is only 142 kilometers, yet the current travel time is 3 to 5 hours, including up to 21 stops in traffic congestion. The new high-speed railway will reduce this to 36 minutes with 4 stops, for which we are planning the new train station in Halim, Karawang, Padalarang, and Tegaluar. It cost this mega project about $7.8 billion, featuring primarily elevated structure, 30 subgrade sections, 13 tunnels, and long span bridges. WIKA, along with CRAC and Sinohydro, responsible for the design, engineering, and construction work under PT Kereta Cepat Indonesia China, or KCIC, as a joint venture company. Since the start of the construction, this high-speed railway project has brought over many new technologies and methods in construction sector, such as the first-time implementation of cast-in-situ method for a full-span girder and Asian biggest tunnel boring machine. For this project, the large number of disciplines involved: structural, concrete reinforcement, and building services, which required significant coordination. On this scale, thousands of its concrete structure could fill over 2 pyramids of Giza. Besides our tight schedule, WIKA faced an immense challenge during project construction. For example, Indonesia has complex geographical locations that impact railway construction, such as steep hills, valley, and landslide. Other countries typically don't have this problem. They don't have many volcanoes and full tropical climate, so the design phase had to be carefully controlled, as we do not tolerate any construction error beyond tolerable value. The track, also parallel with active toll road and LRT, required significant coordination and integration between projects, which even more complicated during pandemic. Under all of those challenges, the President, through his ministry, urged acceleration of the construction increase by 2% per month to meet the G20 event presidency. Before the introduction of BIM and Bentley, the feasibility study conducted at the earlier stage didn't provide much detail about the current socio-economic condition. This resulted in inefficiency and cost overrun. In early 2020, we at WIKA saw a big opportunity for how Bentley BIM INFRASOLUTION will help solve those problems and help speed up this project 6 months earlier at the end of 2022. We use our certification of ISO 19650 BIM Kite Mark to develop BIM documentation and create a standard component library to optimize and speed up modeling. We also use iTwin platform to connect the digital ecosystem in a single source of truth, facilitating digital twin and transfer technology between the two nations. This platform made any requests for information and revision much easier to manage and resolve, removing the language barrier among the whole team. Being able to visualize the completed model not only made construction process clearer, but also helped clarify the order of work, so it could be planned efficiently. So every design had to be created with buildability in mind, with any issue identified and addressed before the construction phase. One hardest challenge is overcoming extreme clay shell in tunnel number 2. If it is exposed, its carrying capacity decreased by almost 80%, causing avalanche. WIKA need to capture this behavior to run complex dynamic analysis caused by excavation. Thanks to Plexis 3D, we added more excavation points, shortening design time, and changed the working method from the 3-bench to the double-side walls and surface grouting to strengthen the tunnel wall. OpenRail is used to automate the manual task to check the CAN transition based on the operating speed. The team created hundreds of thousands of digital assets including concrete sleeper, slab track, and box girder, streamlining the process until manufacturing in our subsidiary WIKA. In construction phase, slight deviation often occur during box girder action. They sometimes require rectification. Open bridge is very helpful in generating deck elevation report to verify geometry control in just one click, which saves a lot of time. Open building with generative component allow flexibility in architectural design in 3 stations. We also leverage model information using the COBie standard, easily used by facility management when the station operates. Design, class analysis, and value engineering, as well as its revision, were undertaken using Bentley Open Solution. We identified and resolved total 108 potential conflicts in the design review stage and helped avoid costly rework during construction. It increased design review quality by 40% compared to the traditional method. Using open rail corridor modeling, we save 10% of fewer cut and fill quantities than any traditional survey data. CDE also enables distributed teams to collaborate seamlessly and helps reduce the frequency of meetings by 35%, especially during a pandemic. With Synchro 40 scheduling, the sequence of materials transport in 55 subgrid sections has been cut by 4 months from the target of 30 months. Combining with Plex's design efficiency, we can save $22 million in labor costs, reducing 1,500 additional workers. Overall, Bentley technology helps improve and shortening construction schedule by 6 months and saving $185 million in construction costs while reducing environmental impact. This Southeast Asia's first high-speed railway is expected to help reduce $500 million in losses due to traffic jam and promote rural revitalization with transit-oriented development. Based on passenger demand of 30,000 per day, this will turn over ROI after 40 years before the concession ends. Although a high-speed railway will not become profitable in short term, this will have a transformative effect on the macroeconomy in the long term. WIKA successfully achieved an important milestone. All 13 tunnels along the line have been connected, and all long-span bridges were finally closed. Nevertheless, cost overrun was inevitable due to external factors. It happened in most high-speed railway projects, but our government believes and fully supports this project, and WIKA strives to reduce it, thanks to Bentley integration. With construction progress nearly 90% in October 2022 and target operation in June 2023, WIKA is optimistic, planning to replicate and apply the lesson learned from this project and use this digital twin as a starting point to build the next high-speed railway from Bandung to Surabaya. And here is the closing video. Thank you.
Some would say that delivering first high-speed railway in just 36 months is an impossible dream. But that's why we attempt to make it into reality. Bentley technology provides excellent tools for efficient and visionary design to fulfill project needs. Leveraging the efficiency of building information modeling and integrated digital solution from Bentley was the key success of this project. Now, the completion is heading toward the G20 presidency at the end of 2022. If this milestone is achieved, it will be a major achievement for WIKA and Indonesia, and a testament to the power of infra construction. Together with Bentley, we were proud to be part of a project that will make the lives of millions of Indonesians easier that have to commute between Jakarta and Bandung. Thank you.